Hi, I'm Christian Elfer at the University of Arizona, and I'm going to demonstrate a CyVerse-based agricultural app that we've developed. It takes an orthomosaic image, soil masks that image, splits it by plot geometries, and calculates a canopy cover for each plot. I've already logged into the CyVerse environment, and I am displaying the data page that shows the folders and files that are available to me. There are three files that are needed for this app: an orthomosaic image, plot geometries, and a YAML file containing experiment information. Plot geometries can be in the form of a shapefile, a GeoJSON file, or a BettyDB URL. The orthomosaic image needs to be georeferenced. We're going to be processing this 1 GB image file. The YAML definition for the experiment information is defined on our OSF wiki. It defines a season, study name, observational timestamp, the collecting site, and an array of plots with their names and species. The plot name is matched with the plot geometries in the plot geometries file and is used to look up other fields that are used in the output. Except for the observational timestamp, once this is defined, you can just use it for as long as you wish. The observational timestamp should be changed for each of the dates that you are processing images. We're going to be using the GeoJSON file. Each of attributes of the geometry in your plot geometry file is search for a plot identifier. When it's found, that plot identifier is used for folder names and output. We'll see this later in the results. If a plot identifier is not available, a default numbering scheme is used. Only the plots whose geometries intersect the orthogonal image will be processed. This means that one geometry file can contain all the geometries for several fields. It also means that we can process orthogonal images that don't cover an entire field. Now that we have our files in order, we're going to launch the app. There's two different ways of starting the Canopy Cover app. One way is to select the app, go to the menu, and say Use App. The other one that I prefer is that we just click on the name. Once the analysis window opens, we'll open up the source files section, and we will select the ortho that we chose before, the experiment data, and our geometry file, which in this case is a GeoJSON file. If you are using a shapefile, be sure to include the SHP, SHX, DBF, and PRJ files. It is critical when working with shapefiles to include all four of those files. We're now going to launch the analysis. On the Analysis tab, you will see that you can hit refresh and we will see our new analysis. This is the new one that wasn't there just a second ago. As it runs, we will get a status. Right now it is running. And we will also get notifications in the upper right-hand page that shows us different statuses related to our analysis. We'll get another message when it is completely finished. Instead of waiting for this to finish, we're going to go to a previous solution that ran. It shows the results will show up under the analysis folder. And it has a format similar to this. It will be the name of the app, analysis, and then some timestamp information. In here will be a bunch of folders that are directly related to the plots. This is where the name of the plots comes in. There's a logs file, which we can ignore. It's generated as part of the run. And unless you're debugging the problem, you don't need to look at what's in there unless you're curious. More interesting results, we have the mask file, the original file that has been masked, the soil mask. We also have a rolled up version of Canopy Cover that has all of the plots in it, their values, and the species that is associated with that particular plot. So here we have 4 plots. They are numbered. That's just how the plots were named. You can use other names. You don't have to keep them numbered. As mentioned before, we have also each of the plots in each of the folders. We have the original image that is clipped to the geometry of the plot. We have a masked image that is the masked original image also clipped to the plot. And we have the canopy cover.csv file, which contains the results for that plot of the canopy cover calculation. So the app I just showed is also available as a Docker image under the AG drone account on Docker Hub and is named Canopy Cover Workflow. It is tagged version 1.4. You can run this Docker image on any system that supports Docker or Singularity. If you have any questions, please feel free to contact us and refer to the links around this video for additional information.